Very good morning, all. So, welcome to the class. I'm sure you are ready now with the implementation of queues and circular queues. Before we proceed further, let me just demonstrate the implementation of queues and circular queue and show you a sample implementation for those who have some doubts about the implementation. So, here is a circular queue, normal queue. So, if I say I have to implement queue, I'll be declaring a max size and then queue array, rear and minor front being declared here as global variables for the time being. Of course, later they should be made as parameters. So modular programming will prefer those to be parameters, but to avoid some pointer-based call reference parameters for indexes, we are using this. Insert queue, we can check whether if rear has become equal to max minus 1, then also queue becomes full. Otherwise, simply increment rear and then store it. Similarly, if it is empty, then we are returning minus 100, assuming it is never a valid value. And otherwise, increment front, store the value, and then return this value. So, or you can directly write return. Display the queue. So, if a front is equal to rear, queue is empty. Otherwise, from front plus 1 onwards, it is filled. Up to rear, it is full. So, I will display the queue values. Compact queue, I can make an operation. Effectively, compact queue means from front plus 1 up to rear, it is a full, and I must shift all those elements from 0 position onwards. So effectively, I will mean that from wherever we are starting, that value should be shifted to 0th index and so up to the last. And then front and rear should be readjusted. One point to be taken care here is that the shifting should start from the element which is stored at front plus 1 onwards, and in that direction I should shift. If I shift from rear backwards, it may overwrite some of the overlapping area, as I told briefly in the lecture last time. So I can simply give choices and then keep on repeating and then give case studies, and while choice is not equal to exit, I can do that just to show you a demonstration. So I can have here the insertion, etc. done. Like at present, if I want to display, I will see that queue is empty. Otherwise, I can have insertion, let's say 5 inserted, again insertion done, 8 inserted, again insertion done, let's say 9 inserted. Now I display. So display means a 3. So I have this key. So if I delete something, so the deleted element is 5. Say at present, if I try to compact, so the compaction will be done and I can again display. So compaction has been done and the list will still appear to be the same. But of course, the indexes have shifted, which are not being visible, but internally they have been done like that. So like this, and when I press exit, I'll be over. So quickly just having a clarity of this, then coming to circular queue implementation. So here I'll say insert CQ and front delete queue. So here also I will have main implementation, insertion, remove, display, and effectively the interface remaining similar. Let's say we are using these, let me just correct that. And here this is a comment, so let me execute this and show you the demonstration. So interface remaining similar, and circular queue will not have a compaction done, but that internally will always work. The point to be taken care here, first thing is just look at the insert queue, and insert queue will effectively mean, I'll just show you one thing, that insert into circular queue. So I have to check if by rear plus 1% max reaches to front, it will be almost full. Of course, one element not being used or one place not being used. Otherwise, rear to be incremented. But increment now always means using percentage operator, and then queue being added with the value. Similarly, for the delete, front equal to rear, then it is empty. Otherwise, front to be incremented, and increment means percentage max, and then val to be stored and returned. One important point here, which we need to look at, is that I should now initialize rear and front as 0 instead of -1. Although you could think that -1 should also work. Yes, most of the cases it will work, but in one special situation, the code is likely to fail. And that is mentioned here, that in special situation when no deletion takes place and rear reaches to almost end of the queue, At that point, after that, rear will be readjusted and it will check whether rear +1 reaches to front or not. So rear +1 will effectively mean that I will go back to 0, but at that point, front will be -1. I'll explain through on the paper also this, but now initialization with -1 is not going to work in all situations. Of course, both -1 still can mean empty also, okay, and if they once they come inside will still perfect fine. So let me show you and explain that by an example or by taking it to the copy and then demonstrating the same thing here. So first let me explain what I'm talking of, the concept related to circular queue and front and rear being initialized. So what I said is, by default in queue, now if it is a circular queue, I prefer if you initialize the front as -1 and rear also -1, of course, not much of a problem because rear will slowly initially -1. Say you added something, you pushed here or inserted some data 5, so rear will come 0. This will become 0. Then let's say you added something more, 20, rear comes here, becomes 1, and so and so. Of course, after that, front deletion, if attempted, front will also come inside, and after that, everything will work well. But imagine no deletion happens. You keep on inserting. You reached to, let's say this was 99. You reached to 98th location, and here also you stored some data 40. Rear is here. So ideally, it is almost full because last location is not to be utilized, and I am saying full. But I can easily see now, if a front is -1, rear is currently 98, insert attempted, let's say I give insert 650. So currently insert 40 is already there. So I say insert 50. It will mean if front equal to rear plus 1% max. Remember, rear is currently 98. 98 plus 1 percentage 100. It will still mean 99. Front is -1. -1 equal to 99. No insertion allowed. Maybe I think fine. Let it be 50 stored here. Now, rear has become 99. So rear is currently 99. Let's say again insertion attempted. Insert 60. Front is currently -1. Q is 100% full, even not a single space left. After that, again attempt will be, while inserting, is it allowed or not? So it will check if a front equal to rear plus 1 percentage max. Rear is 99 now. 99 plus 1 percentage 100, it becomes 0. But front is -1. -1 equal to 0, no, and insertion still gets allowed. And what it will do is effectively this 5 will be overwritten and I will get here 60 stored. So that is going to be a problem if I handled like this. And it is not allowed. So the solution now can be simply that we will initialize for the first time front also as 0 and rear also 0. Not a big difference, still it is empty, still emptiness works well, not a problem. But I say first insertion. The only difference will be first insertion will be done at index 1 instead of 0 because rear will be incremented first. Like you said, insert 5. So if you try insert 5, let me just take this here. So if you try insert 5, this will mean rear will become incremented. Rear will become 0 plus 1 percentage, of course. So it will become 1. And 5 will be stored here. No issues. It will keep on storing like this. It will reach to 99. Let's say this also stores here 50. And now when you try to have insertion after 99, rear has become 99. Index 0 is free. Front is 0 currently. And in that case, I will not face any problem, and one rear plus 1% max will be attempted. That will make it 0, and it will be 0 and front will be equal to that. So now insertion will be stopped and insertion not allowed, and fullness will be okay. So by taking initially front equal to 0 and rear equal to 0 will solve the problem, and no other issue will come by having anything instead of that. Instead of -1, we will prefer this, and otherwise not a big problem. If one deletion happened, after that, the problem happened in this case because front was -1 taken, but rear will always revolve into the range 0 to max -1, and it will never match with the front if a front has not once come in the correct range. So we will do that. Having said that, now we say circular queue and queues have lots of applications, and you can solve lots of problems using queues in applications in operating system, networks, and many other subjects. And one maze problem is also given in the book, so you can study that and try to solve that. It's an interesting problem, like you have been always trying to bring the rat near to the food. You have been solving in your school or in newspaper, you get those kind of a problem. So maze problem is very similar to that, and it is solved using the queues in the book. So try that and try to implement that. So read from the book and try to solve maze problem also. It can be your exercise or practice problem. Or I'll say tute problem. So do that. Good students will be definitely able to do that easily. Now, let's proceed further. So after knowing queues and arrays, stacks and queues, let's have some more understanding about some important discussions. You have been using arrays, single or multi-dimensional arrays, 2D arrays you have been using. But there are certain issues which we will see now. For example, you have made a matrix of some order, say matrix of order 10 into 20. So I know how it is used, but sometimes back in the initial classes, I said, if this is as a parameter passing to be done, I said that let's follow a convention because there are certain issues while passing to a function. Say you are writing void function or int function, anything function 1. We said for the time being, let's always pass it as int mat and specify the size also. Write it at 10 and 20. Don't miss this. Although some of you might have been doing without size also, and you never know which one was correct. So why did I say that write this? Some of you might think that we should be able to write it like this also, and it should work, but will it work or not? Not sure. Why or why not? Similarly, if you had passed an array, say you had a function 2, you passed here some string or some array, some list to be sorted. We have already done that. Maybe you have been writing like this, and this was working okay. Then you say why this should not work, but I say it will not work. This is actually incorrect. Why? And I say this is correct. Then similarly, what are all reasons behind that? So all this is connected in different senses. Let's try to understand what are the issues, and then we will connect with all these concepts. So all these concepts first start with saying how internally stored, how arrays or multi-dimensional arrays, single D, multi-dimensional arrays are stored inside memory. That is an important concept which we would like to now understand. In memory means effectively they are in the RAM, because we always store all these into a primary memory, and that has a lot of connection with above concepts also. So first thing is, rule is all arrays 1D, 2D, 3D, whatever, always to be stored into contiguous memory. Always. And linearly effectively arranged. So effectively there are now multiple dimensions. I have a memory, like if you say I have 8 GB memory. So effectively the memory is stored at addresses, or memory is from 0 to 8 GB minus 1 address. So all these bytes exist. And this is a linear array of this much big. For example, if I say I have 1000 bytes, 8 GB, you might not able be underestimating. So I say a 1000 bytes RAM internally means 0th address to 999 address. So my total bytes storage will be always at address 0 to 999. These are the addresses on which data will be stored. And internally, your arrays are always nothing but, all arrays internally are accessed via addresses. They are kind of pointers, more or less. Pointer mean addresses. So all access of all arrays doesn't happen with square bracket, subscript, etc. It is always using addresses. What does that mean? So even if you write, let's say ARR50, or if you have a matrix 5, 6, this is internally accessed value at some address. And I should know which address. This also will mean value at some address. And which address I must know. So compiler and operating system internally handle all these things as addresses and values at that address. That means if I declare let's say a matrix of any data type, let's say 10 into 20, it means 200 values, 200 elements, of course. Now, inside the memory, inside the RAM, they will be always stored from some starting address onward, which we call as a base address. Let's say alpha. So from base address onwards, it will be stored exact 200, all elements one by one in contiguous memory, guaranteedly meaning the last element is at alpha plus 199 address. For the time being, I am saying element of any data type. So I am saying address means may not be precisely byte, but I say element. Because character data type takes, let's say, 1 byte. Integer might take 2 bytes or 4 bytes or 8 bytes, etc., depending on many things. So internally, this address actually means if this is, let's say, integer stored, so it will take 2 bytes. So next will be 3rd and 4th byte. Next will be 5th and 6th byte. So 200 elements will mean 400 bytes for integer. But 200 elements of character will mean 200 bytes. 200 elements of float might mean, say, 800 bytes, and like that. So I say, forget about data type. that will be automatically implied. So if I have some storage available for each element, I say one element is said to have one address and next address is just +1 to that. And of course, a data type can be later used for byte conversion also. So I say next element is always at address +1. If I say mat, some element was there, so next element is just next. Then the question comes, how these 200 elements are stored? Like if I say I have a matrix of a 10 into 20, this means a matrix like this. 1, 2, 3 up to 19. So 0 to 19 being various columns. And I have total 10 rows. 0 to 9, total 10 rows. Let's say these values are 1, 3, 5, 7, and so and so. This value is 11, 13, 15, 17, and so and so. This value is 21, 23, 25, 27, and so and so. Now, how this will be stored inside this memory? The question is, obviously, this value will be the first value to be stored, but next value can be 3 also. Next value can be 11 also, and like that. Having said that, let's continue on the next page and understand it more clearly. So if I say my alpha is some address on which I have stored values, of course, at this address, element 0, 0 will get stored. Currently, that is a starting value. So this value 1 is stored here. Now, after this, at the next address, that is at alpha +1, which one will be the element that depends on the storage methodology? So we call there are two methodologies. One is called as a row major ordering, and other is called as a column major ordering. So we will understand row major and column major will be similar. Row major means for a 2D matrix or 2D array, row wise it will be stored. Row wise means full row will be stored first, followed by second row, followed by third row, and so on. Effectively meaning after 1, 3, 5, 7, 9, and so, once all 20 elements of this row are complete here, then at 20th, that is 21st element and index 20, I will store 11. Consecutive memory, contiguous memory. So effectively, row major ordering means if you have some starting address as alpha, row number 0 will be fully stored first. Immediately after that, row 1 will be stored, and so, and finally row 19 or row 9. You had 10 rows, so this will be the storage. Of course, this total space is guaranteedly 200 elements, but 200 elements are grouped into 10 groups, each group of 20 elements. Effectively meaning that for a row 0, I will store here element 0, 0, followed by 0, 1, followed by 0, 2, and up to 0, 19. And once 0, 19 is over, immediately next location, guaranteedly 1, 0, and so and so. So this becomes your row 0. This becomes your row 1. And in column measure, it will be different. So you can accordingly see in column measure, that will mean one column stored first, then second column. So column will mean 20 elements, 20 columns stored, each element of 10 elements. So then it will be a different order. Values stored will be 1, 11, 21, and so and so. And once all those values over for one column, then second column and so. Why all this is important? All this is important that whenever you write sometimes, let's say mat 5, 6, this is always converted to an equivalent address for accessing the value. Internally inside the computer, inside the OS, it will not be accessed via subscript or square bracket 5, 6. It will be extracted using alpha plus some address, assuming alpha your base address. So I have to know what is the location at which mat56 is stored. So all program, whatever you write internally works while this address conversion formula. For example, if I say I have element mat00, so this address is guaranteedly fixed, alpha. Of course. Then, what about mat01? Row major ordering means it will be alpha plus 1. I'm saying element, whatever type of element. So an address plus 1 also means plus 1 element. If it is integer, plus 1 will mean, let's say, if integer takes 4 bytes, so it will mean alpha plus 4 as next address. If it is character, it means 1 byte. If it is float, it means 8 bytes. So plus 1 will accordingly be taken here. 1 internally means into size of the corresponding data type. So automatically that process will be taken care. This will be internally equivalent to multiplication of this. But for simplicity, I say, let's treat it as alpha plus 1 data type. Any data type can be used. Similarly, if I say 0, 5, so that will be obviously alpha plus 5. Of course, implied meaning is 5 into data type size. So 5 into data type could be there, but yes, alpha plus 5. And so and so. So in general, I say if it was 0j, mat 0j, this means alpha plus j. What about mat 10? Now 10 will be at which address? It will be at address where row 0 completes. Row 0 completes means all columns of row 0 got added. So if I have declared mat to be of size 10 into 20, it means row 0 meant 20 values. 20 values mean effectively it will be alpha plus 20. You can see this is the address. Row 0 over. Just imagine what about mat 20? 20 will mean row 0 also over and row 1 also over. Means 20 elements of row 0 and 20 elements of row 1. That effectively means alpha plus 2 into 20. So in general, if I say mat ij means what? It means alpha plus I into 20 plus j. J was directly added. And based on I, this will be the address. So internally inside, if you have written somewhere mat 5, 6, it will be value at address alpha plus I or 5 into 20 plus 6. That means alpha plus 26, effectively meaning 27th element. No, sorry, alpha plus 5 into 20 is 100, 126. So alpha plus 126, that is 127th element. And obviously also 5 rows completed, 0 to 4 completed means 5 rows completed, 100 values. 6 means 0 to 6, that is 7th value. So this is effectively 127th value. This is how it is working. And That means we must know this formula for n-dimensional array also. Not only for 2 dimension, but for n dimensions also. Let's consider n equal to 3 and how it will work for n equal to 3. So for n equal to 3, we will formally define and later convert it into n dimensions. Let's say I have a sum array A double R 10, 20, 30. 10, 20, 30. Now, row major ordering will mean I will store in order of first dimension onwards. Means I am total having 6,000 values, 10 into 20 into 30. 6,000 how arranged? Inside this, I will say, if this is your alpha, first it will mean one group or one matrix of 20 into 30 to be stored. That is effectively matrix 0 of order 20 into 30. So similarly, second mat 1 of again 600 elements, and so and so, and finally mat 9. First dimension based. So total 10 different groups where each group of 600 elements. And internally, how this will be? Again, this will mean subgroups, total 20 subgroups. 20 subgroups mean effectively 30 elements of mat 0, 0, followed by next 30 elements of mat 0, 1, and so and so. So this becomes overall storage for mat 0, 600 elements. And within that, again, 30 elements means they will be having boundaries of 0 to 29. So my storage is now well defined and same concept to be applied again. But I need to find the address and uniform or generic address formula. So let's assume I have a matrix of size defined upper 0, upper 1, and up to upper n minus 1. And at a time, I want to find some address for some element. Let's say instead of a mat, I will say it's in general A double R, because it's not a 2D matrix anymore. So I say address of I0, I1 up to In minus 1 to be found. So I'm saying n-dimensional array I'm considering. N-dimensional array. And I am interested to find, let me see if focus can improve. Yeah. So I'm interested to find this. For example, you can assume the size is 10, 20, 30, and so and so. Now, where is the element mat? Let's say n equal to 3, mat 0, 0, 0, guaranteedly alpha. If I have here, let's say mat 0, 0, I2, second dimension, third 0, 1, 2, third dimension or index 2. Effectively, this will be guaranteedly alpha plus I2 because this is going to be within 0th matrix, within 0th row, I2 element. Not an issue at all. Where is going to be 0, 1, 0? A double. Not. Where is going to be ARR 0, 1, 0? Within a 0th matrix, first row will start when all columns of this row are over. And how much was the size? 10, 20, 30. So effectively means when all 30 elements are over, only then this will start. Effectively, this means alpha plus 1 into 30. And if it was a 2, 0, obviously it means alpha plus 2 into 30. In general, if I say ARR 0, I1, I2, it will be alpha plus I1 into 30. 30 is nothing but upper 2. Upper 0, upper 1, upper 2 plus I2. Good enough? So we got something clear for 0th first dimension. Now where will be ARR100? If you see, ARR100 will start at this point after 600 elements. So this is going to be alpha plus 600. What does actually 300 come? This came via alpha plus 1 into 20 into 30. Internally, this is equivalent to saying alpha plus 1 into upper 1 into upper 2. So, ideally, I can now say upper 1 and 2 coming into picture. If it is array 200, it will mean alpha plus 2 into upper 1 into upper 2. In general, if I say let it be I0, it will mean alpha plus I0 into upper 1 into upper 2. Now I say, let's have, instead of a 0 here, I1. I1 will mean this factor coming now, plus I1 into upper 2. And now I2 coming. That will mean plus I2. So effectively, for my 3D array formula is ready. What about ND array? So ND array, I have ARR upper 0, upper 1. Upper means the total size I am declaring, and so up to upper n minus 1. This is the size which I have already declared. And let me just quickly have something like this so that it is clearly visible. And find address for ARR I0, I1 up to IN minus 1. So what will be the address? Now I can easily say alpha plus I0 into all dimensions from 1 onwards. Upper 1, star upper 2, and so up to upper n minus 1. All dimensions. Earlier there were 3, so we stopped here. Plus I1 into all dimensions from 2 onwards, because all elements are its a part in that group. Upper 2 into upper 3 and so up to upper n minus 1. And so plus second last term will be in minus 2 into only one dimension upper n minus 1 and last n minus 1 without any upper factor being coming into picture. So this becomes an overall formula for overall any address for n-dimensional array. Now observe something. First of all, this is equivalently written in the book as alpha plus summation of something using the product symbol also. So I will not explain here and tell you to read from the book also for more clarity and make one line formula by using the symbols, the summation and product. That's easy, but I'm just saying that you should have a habit to read from the book also. So read from the book and that you should be able to represent in that form also. Then one more thing to be observed. In all this, upper 0 is nowhere appearing at all. In the formula, upper 0, this size is not being used at all. Hence, for conversion process, upper 0 doesn't come into picture at all. Now, this indirectly tells me a lot of things. Now we connect to what we said while talking of a parameter passing and array usage while functions on modularity. We will connect there that why all that happened. Now you recall in functions you said I have written one function fn1 where maybe int or any data type you passed. If it was a single dimensional array, size here was not compulsory because this size is first dimension. Internally, you could be using somewhere here, let's say writing array 5. But array 5 will not be directly used. It will be equivalently now used as alpha plus 5. And this formula is ready. No upper dimension needed. Hence, this dimension, the first dimension was not being used. So formula did not create any problem and function can still use all this. On the other hand, if you said, I am using function 2 and here I am passing a matrix, and if I don't supply the size, then internally, if you have somewhere written mat 5, 6, 5, 6 will not be processed. Internally, this needs to be converted into alpha plus 5 into something plus 6. Compiler has to do this conversion. Now, 5 is known, alpha is fixed, known to the compiler, 6 is known. If you don't supply the dimension, compiler is not knowing what will be the equivalent address. And all this has to be done at the compile time before the execution starts. Machine code will have all this conversion done and use it. So the dimension was needed. The upper one dimension was needed. So if this matrix was 10 into 20, this 20 must have been told, only then this conversion will work. So writing here 10 could be choice whether you write or not. So that will mean if you write your function fn2 to specify clearly mat 10 and 20, this is perfectly valid because we specify every dimension whether used or not. So we said no problem. This is perfect. Even if you write it as void fn2 int mat first dimension not listed, but the second dimension listed, still okay. But if you write function 3 or function 2 in this form without specifying other sizes or second size also, this will be syntactically incorrect because compiler is not able to equivalently convert, and which is an internal logic need. Hence, this is incorrect. So anytime you are passing ND array as a parameter or ND array being used in function, if you are declaring function, then declaration of the function must have all dimensions except first. Because first dimension upper 0 is not being used, hence even if I don't supply that, it can work. If you supply first dimension also, no problem, but others are must. Hence it becomes important. That's why I always said that always use this, you will have never a problem. But sometimes by mistake, if you start using this, then it was a problematic. So if you had some function 3, which was being passed as a parameter of a 3D array, let's say array 3D, then first dimension may or may not be supplied, but the second and third dimensions must be supplied, must be mentioned while declaring. These are must. And this is optional. Not only that, the dimensions must match from the past parameters. Because if that doesn't match, the address conversion will become wrong. What does that mean? I mean that if you have declared function fn2 to be of size mat, let's say something, but here 20, and from main you have some variable mat1 of any size 15 into 20, and other one is mat1, let's say 15, 15, mat2 being 15, 15, fn2 being passed mat1 is okay, but fn2 being passed mat2 will be incorrect because mat2's internal dimension is 15. Your formula or actual storage is 15 columns based. But here formula used will use 20. Hence, this passing will be incorrect. So remember, you have to be always careful for multi-dimensional arrays. First dimension size, even if changes, not a problem because this was not used at all. So that won't make any difference. So remember now, this was the reason we focused on that. A connected concept is also there that some of you have a habit of doing programming by declaring or having an array based on the variables. Like some of you have been doing a programming in this form. Say, if you wanted a 2D array or 2D matrix to be declared, say you will declare int rows columns, you will do scanf, and you will read your rows and columns with proper syntax. And maybe you declare 5 and 7. If you give value 5 and 7, some of you will declare your matrix as this. Of course, you save memory via this process. You don't use extra memory. So perfectly fine. You did your coding for matrix, etc. Perfectly fine. Not an issue at all. But if you use functions and mat to be passed as a parameter, then you are going to face problem. What is the problem? When you pass it via function, say you have void function 4, and here if you write int mat rows and columns like this, it is incorrect. It will not be acceptable. There will be a syntax error. If you try to remove syntax error somehow, there will be again probably creating a problem, because internally any excess of mat ij element is being converted using this values rows and columns. Inside this function, rows and columns are not known. They are no more variables which are accessible. Rows and columns were accessible above. Internally here, the formula got converted into using words rows and columns, but rows and columns variables existed there. They will work. Here, this size, this variable is not directly accessible, because here this needs to be defined as a parameter, etc. Even if you declare int rows, int columns, still you are not allowed to write here rows and columns. And if you try to write something empty, not allowed. If by mistake you write here, let's say I don't write here, and then say you write here 20, internally it will work with value 20, but later your program will supply input as a 7. Input you will supply at runtime. This formula conversion has been already done at compile time using some predefined value like 20, etc. A mismatch will happen and your code will fail. You might try to access, let's say, mat 3-4 element. Here 3-4 element could have been value, let's say 25. But here 3-4 element could mean not 25, some other value, because it goes to a different address. Hence, your all code can fail, and inside the function, this address could mean something different. So you have to be careful, and I'll show you this through a sample code, which will make things probably more easy for you. Let me just open this and show you one example. So I say, for example, here you have declared rows and columns, and then you say enter number of rows and columns. And then you read number of rows and columns. Perfectly fine. Then you declare your matrix as rows and column size. Perfectly fine. And you try to find summation by reading this. If you find a summation without using function, code works well. But if you write it using function, say diagonal sum you want to find, if you write it like rows being passed, columns being passed, and mat being passed like this, when you try to compile, you get error. It says this you can't write. Even if you try to think that I will write here int rows, still it will not compile. And this doesn't work. So this is incorrect. Maybe you think, fine, let me do it like this. Fine, this could work because first dimension was not compulsory. Fine, but second dimension, and you can't leave this dimension. Now, if you compile again, there is an error. So you are not able to do that. Rows is there, so I can do, but here I can't compile this. Maybe you think of writing here 20. Fine. If you write here 20, now while passing this, you get a message that earlier your matrix is of size mat 1 with columns as a second dimension. First dimension doesn't matter. But now you are trying to pass it to a matrix with column size as a 20, which is incorrect. So this message itself speaks what I have explained. So you are not supposed to handle things like this. So make sure that whatever syntax and programming you do, you know the concept behind that. Otherwise, don't just assume something and don't just use without knowing the concepts behind this. So multi-dimensional array passing to the functions and modularity, you have to be careful to use all these features. Having said that, I think now I'll go back and wind up. So having completed this, now I'll stop. So I'll give you some practice problems. Of course, I am not saying today as a homework. So I'm saying your tutorial or practice problem based on today's lecture I'm telling you to try 3 questions, question 1, question 2, and 3 on page 86 of your book, where all these are based on this concept which we discussed. And question 3 actually says design a formula for column measure ordering. So you should also try that question, and question 1 and 2 are also similar. So you should attempt to solve those also. And I'm sure good students will try and definitely solve. And secondly, I have also said already, read the book and also make a 1-line formula for row measure ordering also, where 1-line formula will obviously use your summation symbol and product symbol to write the n-dimensional row measure ordering based. So try with this, and I will stop here. And the next class, we are going to start with the pointers. A lot of concepts of pointers will be discussed, followed by the linked list implementations. Bye-bye. All the best to all of you. Have a good day.